Hi, my name is Noah Gift, and today I'm going to talk to you about how to take logic, really an input, a unit of work, take that logic in Python and push it live. And so I'll take you through the step of creating a scaffolding for a project, wiring together some stuff with Boto3, taking that code, turning it into a command line tool. Then once we have the command line tool, deploying it automatically using FastAPI via AWS App Runner, and also showing how you can do that same logic with AWS Lambda. So really soup to nuts, how do you supercharge your Python for DevOps workflow and bring your logic live? Let's go ahead and get started. In my opinion, if you master a function in Python, you have mastered essentially 80% of the language, and it's a great way to be really, really efficient. So how do you master a function? It's very straightforward. So let's just build this out. All you need to know to master functions in Python, which again is 80% of the language, is that you have basically a unit of work right here, unit of work, and then you have a input right here. This is the input. You have, and this would be step one. You have a unit of work. This is step two, and then you have an output. Right, and we see this pattern in lots of things, right? You have a hose works in a similar way, or a dishwasher works in a similar way, right? Like let's take a dishwasher. This is a good example of a very similar concept. Is that what happens? Well, the dishwasher has the water that comes in from the water system in your town, and then it goes into your house, and then here we go. We'll call this DW, the dishwasher. You put stuff inside of it, it then does its work, and what's the output? It's got clean dishes, right? So exact same concept we see with Python functions. And once you understand this concept, input, unit of work, output, everything opens up, and you can do amazing things with Python. Lambda functions, you can build distributed computing, you can do machine learning, you can do DevOps stuff. There's so many different things that are enabled by using a Python function. So where we left off was this concept of, again, a function is a unit of work. There's an input, unit of work, and then there's output. This concept, we'll see it all over the place over and over again today. And so let's get back here into what we're covering. And so I'm going to move into here, which is now, let's take a Python function. And you can see here, this is a really, really simple Python function. I put in the word times, and then I go through here and I say, I like to practice, this amount of times a day. Pretty simple to, make an intuition about, right? Again, input, unit of work. Here we go. I practice 2 times a day. I practice 3 times a day. It looks pretty simple. One of the problems with positional arguments, though, is that they're brittle. And this is what I mean. If we go through here and I say def practice and I put in 3 different values, this works at first, right? I say I like to practice the piano 3 times a day for 45 minutes. So, okay, great. I wrote a function that does something useful. But look, if I swap the order around, all of a sudden now things are non-deterministic, right? So basically, I like to practice 7 piano times a day for 60 minutes. Things are not the way I expected them to be. And this is why people in general would prefer to use keyword arguments, because then they're processed by the key, and you can also have default values. So I prefer this many times when I'm building a function in Python is to use the key value pair technique, because A, you actually get default values, and B, you don't have to worry about order anymore because it's not parsed in order. And so if I go through here and I say practice, say I like to practice Python 2 times a day for 60 minutes. And if we go through here and I say practice duration 90 times 4, notice that I can swap the order that I call the arguments, and I actually don't always have to even call them out. So it's just, I would say, a more efficient, for the most part, to actually use keyword arguments for Python. Now, the other thing that you can do as well is you can actually pass in a bunch of arguments. So here's an example here. We say asterisk, asterisk, keyword args. And then if I go through here and I pass in an arbitrary amount of key value pairs. Look, I can just pass as many as I want inside of here. And this is kind of a neat little trick to be aware of as well when you're using these asterisk keyword args. And I think a slightly better way to use it though would be to do things with the attack here. So where I put it all into a dictionary, and then I just pass that dictionary inside of the function that I wrote. This is a little bit cleaner. If you are going to accept arbitrary amount of keyword arguments, you may want to just put in your docstring pass in a dictionary. So the other thing you can do that's kind of cool with Python functions is that you can build around basically a function as something that's like think of it as like a baseball, right? Or some kind of a ball where you just throw it around and do things with it. So here's an example where I have a function that accepts a technique, and you can see here's the dictionary, and I say if technique and attacks, return attack technique. Now, if I run this, you can see at Kimura, it finds this and it returns back the arm attack. If I go through here and I say attack location, bear hug, there we go, unknown, right? So if it doesn't know it, it'll return back an unknown value. So, that's maybe somewhat useful of a function, but I can also write a function that assumes that someone else did a lot of the work for me. So in this case, we could say, look, this function takes a function that categorizes attacks and returns the location. So I now have 3 attacks, and I say for attack in new attack list, attack location, and then I basically assume someone will give me the smarts. And then I go through here and I say the location of attack is a rear naked choke is unknown. The location attack of Americana is unknown. The location attack Kimura is arm attack. So it's able to actually use the other functions. So that's one of the really cool things in Python is you can have functions that accept other functions. You can even go further though in Python by using this concept of functional occurring. And so this would be basically a function that has another function nested inside of it, and it can keep the state. And so this would be a good example of maybe if you were going to build the logic for a computer game. Let's say you're building your own Python computer game. You could use something similar to this. So how would this work? Well, you could build an outer function like this. We say def attack counter and say lower body counter 0, upper body counter 0, and you say inner function. So here's the inner function like this. And let's just take a look at just this inner function. What happens is I assign a non-local variable here, and then what I do is I say if there's an attack in attacks and it's an upper body attack, right? So if it's one of the ones that matches upper body, then go to the function above, which is the outer function, and increment the counter. If it's a lower body attack, increment the lower body attack counter. Finally, go through and return back basically the inner function. So this outer function keeps the state around and returns back the inner function. So if we go through here and we run this, what happens is I first have to tee up the function, and then there we go, and then I say type fight, right? And so type function. So basically this outer function returns the inner function, and that gives us the ability to do things like this. I can say upper body attack 1, and then I run another attack and I say upper body attack 1, lower body attack 1, right? I put another one, upper body attack 2, lower body attack 1. So really pretty cool concept here when you use these closures is that you can keep around state of the outer function and the inner function does all the work. And this is important because it has some similarity to how, like, for example, a decorator works in Python, which is something you'll see quite a bit. So really, this is what I was mentioning earlier, is that the functions are 80% of Python. Once you understand Python functions, you can really do a lot of stuff. And so let's take a look here at this partial function here next. This is another neat little trick you can do with functions, is especially it works for like workflow automation or building pipelines of things. If I say from functools import partial, it allows me to partially call a function. So in this case, look, it takes 2 arguments, but if I want to actually only partially call it, I just say functools.partial. Notice that it returns back a partial function, and look, it doesn't throw me an error or anything, even though I only called it with 1 argument. And so if I run this though, now it actually runs. I also could run it the other way, and I could call both arguments. So I can basically not change the behavior of the original function at all. I can just it does what it does. It takes 2 arguments, but I could also call it with partial and say, look, in this particular context, I want to maybe call it iteratively because I'm sending it through a pipeline of work, and so what you can do in this case as well is basically iteratively process this. And so that's yet one more fancy thing you can do with functions. Now here's another example of something pretty cool you can do with functions using lazily evaluated functions via generators. And so why would you want to use a generator? I think the main reason people use generators is dealing with infinite data, and with cloud computing, this is something that does actually come up quite a bit. Is let's say you're grabbing a bunch of stuff from Amazon S3 and it was a petabyte of data. Well, you don't want to pull that into memory. Your machine will just blow up eventually. What you would want to do is potentially grab little pieces of it and process little pieces of that data at a time. So that's exactly what a generator does. So if we take a look at this, here we go. We have a lazy function here, and I import random. And again, I have that same attack decorator, and I say, while true, randomly give me back a list of these attacks and then yield it out. What happens is I run this right here. I then do the type, and I notice it's a generator. So that's what the yield does, is basically it takes an infinite sequence and it yields back 1 item at a time. If we go through here and I say for underscore in range 6, there we go. Look, every time I run this, it gives me an infinite amount of data. I can run this forever. I can run this as long as my computer exists for the next 10 years, and it would just always give me new values because we're doing a while true, which is infinite. And in this case, it's randomly giving me back results. Now, similarly, this is, once you start to understand that these functions are things that either are embedded or wrapped, and that's really how a lot of them work, is that decorators essentially just engulf one function and do some stuff to it. And really it's like a big fish grabs a smaller fish and eats it. It's kind of that same concept. And so in this case, let's go through and let's add a decorator. This one's a randomized speed attack decorator. And all it does is it engulfs the outer function and adds some sleeps inside. That's it. And so if I put this inside, I say at randomized speed attack decorator, and that's how you put a decorator on top of a function. You just say at, and you put your function here. Now notice it accepts a function, and then it has an inner function that does all the work, and this takes all the arguments and the keyword arguments. So again, it just basically wraps it up and then returns back this value. If I do this, well, what happens here now, basically the same thing I was doing before, but now it has a non-deterministic component to it, which is that it will always randomly add sleeps into what I'm doing. So this kind of a technique is actually, it's actually not just cool to do, it's actually useful if you wanted to write some code that wanted to maybe like instrument a microservice and you wanted to figure out like how it performs. You could write a test script that could randomly call it and then see how it behaves over time. Now the other thing you can do with a decorator is write a very simple timing decorator. I think this is potentially one of the most simple ways to learn how decorators work, is to use this particular example. So I think this is a great example for you to play around with. Now let's go through here step by step and check out what it does. So we say from functools import wraps. This is something that you need to do if you want to preserve the name of the Python function you're wrapping. That's the only reason you need to call it. In this case, because I'm going to write a timing decorator or my own instrumentation, I do care about it. So I just have to add this at the beginning which is not that big of a deal. So this F here is the function, right? So this basically will accept some other function. And then here's the thing that does all the work. Right? This is the only part that's really important, is I accept the arguments, I accept the keyword arguments. I set up a timer right here, that's the from time import time. I say results. And then in this case here, I basically go through here and I accept those arguments, and then I time it, and then I go through and I add a print statement. So basically this is just instrumenting what's happening in my code. If you wanted to write your own custom stuff that did all kinds of fancy things, this would be a great little template to use. So let's go ahead and run it. And now if I want to put this on top of something I did earlier, all I have to do is say @timing. And again, it engulfs this function, and then it goes through and it says, okay, this was passed in, attacking after 3 seconds, it runs that stuff. And then here we go. Here's our instrumentation code. It says the function's name was called SumAttacks. The arguments that were passed in were bar. There were no keyword arguments, and it took 3 seconds to run, right? So a great way, in my opinion, to really master functions is to get an understanding of how decorators work. And then once you write your own decorator, then it's easy to do advanced things. You can also do weird things like this with functions. So you can make a class behave like a function, and the way you do this with this under call method, which makes it behave like a function. So if I can run this thing, I could tee up a function, and basically it runs. You can make a class behave like a function. I don't really find myself needing to do this, but for completeness, I figured I would show this in there. The other thing that you can do as well with functions that's pretty cool is that you can actually apply functions to a Pandas data frame. And this is, I think, one of the more interesting ways to deal with functional programming is, notice here that I have Pandas data frame, and I say iris right here. So this is a really common problem. In fact, almost any data science documentation you'll see anywhere, they use the iris data set and they do something with it. Now, here's where it gets interesting for functional programming is, if I want to manipulate anything, I want to manipulate this column, whatever, you don't want to write a for loop because it has very bad performance. And just the way Pandas work is it expects you to do a functional programming. So basically take a function and apply it to either a column or to the whole data frame. And so if we look at this, look, the iris data set has 150 columns. It has, 150 rows. It has 5 columns. Right here we go. 1, 2, 3, 4, 5, and it has 150 observations here, or rows. If I click this, see this apply, all this does is take a function, which is the round function we used earlier, and it rounds everything that appears inside of it. And so this apply is pretty subtle, but basically it's doing row by row. Every time there's a row, it actually gets this function is called. And so this is getting called 150 times. And look how quick it is. It's extremely quick because of the underlying NumPy library. If I look at the shape, look, it created a 6th column here, and that's the rounded sepal length column. So this is a little bit subtle, and it's hard to figure out what's going on unless we write our own function from scratch and then use apply. So how do we do this? Well, let's scroll down to here. And this is pretty intuitive, right? We have a function, which is multiply by 100. And if I go through here and I say, look, it's going to accept an X. So this is exactly what I was referring to earlier. And in fact, let's just take a look at it again. A function is an input. Right here, we have a unit of work, and we have an output. The same thing's happening here. We have a function. It has an input. In this case, the input is an X. Here's our unit of work, which does this stuff. It multiplies it by 100, and then the return value is the output. And so if I run this, notice what I do is I create a new column right here, which is 100x sepal length. I then take the original sepal length column and I run the apply. Now here's where it gets interesting, is I pass in this function. This function will be called 150 times. If I run it, there we go. Now we have 100x. Extremely fast because of the fact that it uses functional programming and there's no for loops. It basically applies that function to all 150 rows in a very efficient way. Now, if I take this out, we can see it happen in real time. Take this out, I print it, now look what happens. It called it 150 times. So we can see this every single time it's called. Right here is what's happening. So really, functional programming is a great technique to be aware of. And once you understand that, input, unit of work, return, all of a sudden this whole new world opens up here, and you can do all kinds of things with it, group it, etc. So this is probably a good spot here to maybe scroll down to our next section for a second. Let's scroll down here and go in automating text and file system. But before I get to this, let's go a little bit deeper on the function by building out our own repository from scratch and testing out a couple things. So what I'm going to do is I'm going to open up a new GitHub repo, and I'm going to call this functions, and we'll say 12.2 2021, and we'll just say this is an example of Python functions in GitHub. And a couple things that I'll do here is I'll just create a README file, git ignore and we'll have Python as our language, and then I can just create the repo. Now, one of the things that I think is a pretty cool trick that we can play around with here is that GitHub has something called GitHub code spaces. And in my opinion, for like doing DevOps stuff, cloud editing is the way to go. If you don't have the pro version of GitHub, don't worry, like you can just do something similar with your own computer, or you could use AWS Cloud9, or you could use Google Cloud Shell or Azure Cloud Shell. But basically everybody now has some kind of a cloud-based editing environment. So what I'm going to do is I'm going to use this code space here and spin this up, and you'll see how it works. I guess it's the equivalent to doing Colab Notebook, but for more programming. So in this case, it would be using more for a software engineer, a development environment. And I can actually just close all this up here. And here we go. We've got our open project here. Sure, I'll activate this Python tool. So what I do when I'm building out a project is the first thing I do is create a small scaffolding. And this is actually less work than more work. And so what I do is I do this. I say touch makefile, and then I'll do touch requirements file. So these are the two projects, two things I put into a default project, and then we'll create a hello file here. So to start out with, what I would recommend, and we'll go to another project I have where I can just grab some examples, is that I would typically just go to this makefile here like this, and I would grab my own makefile from some other project I was working on, and I can just paste it inside of here. So once you start to create your own makefiles, you'll notice that you'll basically do the same thing every single time. So I'm going to start off though with this. I'm going to start off with basically some PyTest stuff. We'll just put this inside of here. We'll comment this out. I don't need any of this. We can just get rid of all this stuff, and I'll create a scaffold here. I would say test formats and lints are all probably pretty good ones to get with. So the first thing that I do with a makefile is I'll have an install step that looks at requirements file. So let's go ahead and do this. Let's just say PyTest, Python black, which is formatting, and maybe PyLints. There we go. Those are good to start with. And notice what I do is I say pip install -- upgrade pip, and I say pip install -r requirements.txt. And so I'll run this to install just some libraries that help me write Python code. So if we go through here and I do, if I want to run this, I always run a virtual environment first so that I don't get myself into trouble and I have weird library dependencies. And so the way I do this is I say virtual env tilde slash dot venv. And then what I will do as well is I'll actually go to my bash rc file, and I will actually just source it at the bottom. So right here, what I'll do is I'll say source virtual environment, and that way I don't have to worry about it ever again. It's just annoying that I have to do this, and I do this to get rid of package conflicts. There we go, source tilde dot venv bin activate. Now, how do I know this is working, or what do I do? I just open up a new shell. Look, there we go. We've got it working, and I say which Python. We know that this actually works. So I can basically get rid of this one, go back to my other shell, and I can actually just type in bash, and that's another way to source it, because now it's in my bash rc. Now that I've got that set up, the Python virtual environment, I just say make install. And what this will do is it'll look inside of our requirements to see what libraries are installed. And again, we put these libraries, PyTest, Black, PyLint. There we go. And now that I've got this cooking, I can actually build out a really simple hello function. So we can do the same stuff that we were talking about earlier, that, you know, basically unit of, there's an input, unit of work, and there's a return. So let's try something kind of fun here. I'm gonna go to the requirements, and I'm gonna type in IPython, and this will allow us to play around with some of the techniques that we did earlier. So let's go ahead and do a make install. So I'll say make install here. And the reason why I like to use IPython when I'm writing software is that I can play around with ideas really quickly. And so I can just go like this, run IPython. And once I do IPython, then I can go through here and I can say things like, I don't know, like what about string reverse? If I want to reverse a string, how would I do this? Well, let's do a phrase here and say, I don't know, red, right? Or let's make it like this. And then if I want to do a string reverse, how would it be? It would be phrase dot reverse. Does that is that a built-in reverse? No, it does. There's no string reverse. Well, how about capitalize? Well, capitalize. Let's try that. There we go. So this capitalizes things. So let's keep something really simple, and let's write a capitalize function. So I would go here and I would say def cap it, and then I would take in a word. So I'll add a little documentation here and say, you know, this capitalizes a word. Okay, and then from here I just say return word dot capitalize, right? So this is a pretty simple function. It basically doesn't really do much. It basically uses the Python standard library to do all of the work. And in fact, I could put a little print statement inside of here just to make it do a little bit more work and say, like, you passed in this word, and we could put this into here, and then I could actually say, you know, work is here, and we could actually say this and just assign it here so that we can do something cool with it. And then I say like a print statement that says this is the new version, right? And so we go through here and we say word, there we go. And then at this point I say I just return back the work. There we go. So basically this is kind of a neat little function in that it really uses Python standard library to do everything, and all it does is print in like the before and afterwards. In this case, this is the new version. This would be work, like that. So now that I've used IPython to help me, I can exit out, and I can basically go to IPython again, and I can play around with it. I can say import or say from hello, import hello, like this. Wait, from hello import cap it. There we go. And then I can say cap it and we can say results, and we can say like again, Bob or something like this. You pass in the word Bob. This is the new version. So in this case, Bob was already capitalized, so it doesn't get us anything. What happens if I say result 2, and then, whoops, result 2, and I say Bob with lowercase? What happens? There we go. We were able to pass in the word Bob. So again, this is really a simple function intentionally. If I do result 3, we can say result 3 is equal to cap it and say, I don't know, cherry. And then this would go through. There we go. You pass in the word cherry, and this is the new version, cherry, right? So I like to use both at the same time. I'll do the scripting inside of here, but then I'll come back. And to me, this really lets me test out that concept unit of work with an input and an output. And in fact, this lends itself to the next phase of, now we're starting to get into some DevOps techniques here, which is that I think it's always a good idea to lint your code. And let's go ahead and do this. So what does linting do? Is it checks for weird errors, like subtle errors that get cropped up inside of your code. And so, for example, if I said var equals var or something like that, basically this means nothing. And now if I run make lint, what happens? It says, hey, you can't do that. Like, that doesn't mean anything. Like, and in fact, even if the var was assigned, if I said var is equal to 1, right, this would in theory still work, right? Because basically if I run the capit code here, if I just run this, it will, I'm sorry, hello. If I run hello, it still runs, but it's just syntactically messed up, and this could cause a time bomb for us. And so this lint here basically catches us from making a really bad mistake. And so that's why it's a good idea to add linting, and it will save you time. It's not more work, it saves you time to do it. So I always do this step. I have an install part of my code base, and I have a lint part of my code base. I also do this. I also do the format. I think it's a very good idea. So we've got this formatter installed. Let's go ahead and do that. Let's do make format and say make format. There we go. There we go. It just cleaned it up a little bit and makes it good. So between those three things, linting, testing, formatting, and those are a great way to kind of get the ball rolling. Now we can move to the next thing that we could do with this, which is write a test. And this is also taps into this concept of a unit of work when you write a test, in that basically, because we know it's an input, it works, it returns, it's very suitable to testing. And so how do we do this? Well, we can just write a test real quick and do test hello.py. And from here, pretty straightforward with pylints, all I need to do is say from hello import capit, and then the test is using an assert statement. So I say test capit like this, and then I just write an assert. I just say assert that cherry. Actually, first let's make an incorrect test. Let's say this. If I put in the word cherry here, it's going to capitalize it, so this test will fail. So let's go ahead and run this test, and let's just double check to see what a failed test is. So we need to look at the make file here, and notice here I have Python. Let's do the right command. It's going to be Python -m pytest. This is the testing module, and then I'm just going to give it the name of my test file, which would be test hello. That's it, like that. And if I go through here and I say make tests, it needs to be the exact file name. So there we go, make tests. Look, it gives us a great output here. It says, look, you said that it would be cherry with a lowercase, but it's actually uppercase. Look, here's what happened. This test is actually a failed test, right? So really, really helpful output here, which again is a very simple function intentionally, but it shows us the value of testing here. So we can fix this. We know this is not what I intended, And let's go ahead and write the test. Now let's go here and say make test. There you go. So really, I think the function, once you start to capitalize on this thing, it really is very suitable to DevOps as well, because of how easy it is to lint it and also how easy it is to test it. And so these are the steps that I would recommend all Python projects is have something like this, is have an install, makefile step, a test, a format, a lint. And look, you can do install, lint, test, and format. We can now do make all. And so another person on my team, all they have to do is do a git clone, create a Python virtual environment, and do make all. So let's go ahead and try this out. If we say make all, how does it work? There we go. It's going to go through. It's going to try to install. It's going to go through and it's going to lint it. It's going to test it. And it's going to format it. Everything's great, right? We have a full working project. So this is basically continuous integration because it's local to my system, local continuous integration. The next phase to bring it into like a DevOps best practice would be to move it into what I would call cloud-based continuous integration. So how can we do this? Well, fortunately, GitHub makes it pretty simple, because if we go to here, repository, we can actually click on actions, and we can actually set up the actions. I'm going to go back here for a second and push my code into GitHub though first. So let's go ahead and do this. Let's say git status. Let's say git add, and I can say star because I added the git ignore file, and then I can just say git commit. Say adding initial projects. Let's go ahead and push it. There we go. We push this project, and now if I go back to this and I say go to repository, it'll go back here. We see everything. Now, to test it using GitHub, they have something called Github Actions. This is their cloud-based continuous integration system, and highly, highly recommended. And look, they even show you like how to build a project with a makefile. Here's how to use Anaconda. Here's how to publish your own Python package. So if you wanted to build your own library, you could do that. These are all great examples of it. You can even deploy to cloud-based environments. There's just a ton of different examples. What we're going to do though here is I'm going to click on setup workflow for yourself. And again, I'm going to be lazy, and I'm going to go back to some other project I already had set up and go to GitHub workflows here. And I could actually just grab one of these things. And let's actually make it fancy. Sure, why not? Let's take this fancy version of our project and go to here, and I'm just going to paste this over it. And let's take a look at what this does. So what this particular test does is it says, I'm going to test my project with multiple versions of Python, which in fact probably is not a bad idea as a default. Anytime you're doing testing, is why not test it with multiple versions of Python. And then what this does is it says every time I push, run this, and then for Ubuntu latest, this is where I want to actually test it in that particular operating system. And then this is a matrix, is going to test it with Python 3.7, Python 3.8, and Python 3.9. And then how do I do this? That's what this substitution does here. It says matrix dot Python version. So it's able to call this inside of here. And then we just do all the things I just talked about. We have a make install that installs our code. We have a make lint. This lints our code. We have a make test. This tests our code, and then we have a format. So we're testing the installation, and we're testing the linting, and we're testing the testing, and we're testing the formatting. All of these are all things that happen just by this really small little YAML file. If I click on it, we can say, creating cloud-based CI pipeline, right? So this would be the beginning of DevOps, which we're trying to continuously improve our project, Kaizen, continuous improvement. Let's go through here. Let's take a look at this, and we can watch it. It's going to do 3 concurrent build jobs, which is pretty cool because it's going to test Python 3.7, Python 3.8, and Python 3.9. Let's grab 3.7. Sure, let's take a look at it. It's going to do everything we just did inside of GitHub code spaces. It's going to install the dependencies. It's going to, after that's done, if it's successful, it will lint with PyLint. and it will format our code. Perfect. It looks like it's all good. You can see that this one actually passed. If we go through here, I can actually create a status badge as well. And I just copy this, go back to this main file here and put this into the README file. And so you can see there's, in my opinion, no excuse to not do this for every project you work on. Sometimes I'm working with people that are new to Python and they don't want to do this. Like, oh, it's too much work. It's like, no, it's less work to do this because now you have automation making your code constantly better. If you don't do this, you're really going to eventually get into a situation where there's real problems with your code. Now, if we want to test out what a failure looks like here, pretty easy as well. We can again go back to our test file here and check this out. Because it's hooked into the automation, I can just play around with ideas here. So like, hey, I want to test out what happens if I make this lowercase. Well, let's take a look. Let's see what happens. So if we click on this, the action gets triggered again. Here we go, update test hello, and we're going to see this thing fail because of the fact that that test, the logic of the test is actually going to fail. So the lint will succeed because there's nothing syntactically wrong, but the business logic, there's a problem, and that's where we'll see the test fail. So let's go ahead and verify that. Perfect. We see, in fact, assertion error, right? So we knew that was going to happen. And this is a great way to test your deployment system as well, as like verify that it actually does catch these kinds of problems. It's easy to fix. We just go back here and I go to this test file and I can actually fix it. Now, let me show you one other cool thing. The f-string formatting, one of the things that's interesting about it is that basically it doesn't work. I think it was Python 3.6 that it had that implemented. So on older versions of Python, our code is not going to work because it has f-strings inside of it. So one of the things I can do is, if I wanted to verify that real quick, I could actually do this. I could do Python 3.5, which I think will work, and let's see if we can blow this thing up. So we also could test older versions of Python. There we go. Here's a Python 3.5, and we should be able to see that actually these three versions of Python work, but this version of Python should fail because it doesn't know what an f-string is. So let's double check. Okay, Python 3.5, install dependencies. Well, it blew up. It actually blew up for a different reason. It blew up because the Python black library doesn't work with Python 3.5. So we found a separate error that was a problem here. So there's a bunch of things that you can suss out by using this matrix style testing, and it really is a great little idea for your project. So it's very straightforward to do matrix testing. It's very straightforward to use Github Actions. And it's very straightforward to set up the scaffolding. It really took like 20 minutes to get this going. I would recommend all things that you build use this kind of concept. So, okay, so we have this. We have our unit of work, which is really the center of the universe for DevOps. Once you understand this concept, input, unit of work, output, really you're in a great position, because now you can do things like you can add a test, you can go through here and you can add a lint step, right, which is what we just talked about. You can format your code, and you can put it all inside of a test framework that gets run inside of the GitHub code spaces or the AWS Cloud9 or one of these other environments. So really, this is the I would say the kernel of being able to build DevOps functionality. Once you can do this, really the sky's the limit, and you can build more and more complex things. So I think what we can do here is we can go back to the notebook that I was working on earlier, and now let's dig into a little bit more functionality of stuff that you can do, and then we'll keep incrementally adding to this repo. So the first thing I'll take a look at here is this section called automating the text and file system. Really common to actually do things with the text and the file system with DevOps, and in particular, like the ability to read a text file, read a CSV file, read a YAML file. All this kind of stuff is really important to know how to work with. And so let's just go through here really quick and see to write a file in Python, you could do this. You could say open, name a file, make it writable, and just put lines of code in there or text, and then close it manually. The problem is that if you explicitly close files, it's easy to forget, and then you don't write the file. And so in particular, even if you have something more complex like this, where you have a huge list, still it's very easy to forget this, and it's clumsy. There's a much better way to do this in Python, and the way you do this is that you write a file by using something called context. And notice how this works. It's only 2 lines of code. You just say with open, and you put the file name, you do make this writable, and you say workfile.write like this. And what this does is allows you to easily increment things to a file. Here's a good example as well. Reading a file in, I say this is open, read the lines, say for line and out, print line, f.close, and this particular file is able to go through here and read, but again, I have to actually close it. It's much better to use context for that as well. So really, if you're using a file handler in Python, this is definitely the way to go. Say with, open, do some work, whether it's reading or writing. Now, another thing that comes up a lot is, this is, especially microservices, is you have a dictionary in Python, and you need to be able to, work with that dictionary and kind of go back and forth. So how do you do this? Well, in Python, you just do this. You just say my dictionary, you import pickle, and then you can just write that out to disk. And again, very similar. You just say open, and now take a look at this. You can see that it's now on disk here, that dictionary. And if I want to load it up again, I can just do this, pickle.load, and then load it back. So this is really nice for quick and dirty things where you need to just persist something in Python, and you don't even want to bother to write it to a file. Here's an example of serializing a Python dictionary to JSON. This is really common as well. A lot of times I'll do this. I'll make a file called data.json. Look, we can do that same context type thing. And then look, if I put this into the cat command, look, I can read it from disk. Similarly, I can open it back up again, and now it's a Python file. So I think this is one of my favorite ways to deal with microservices, is to build out some JSON stuff, to test things out. Again, later if I want to write a test or whatever, I can do all this with a Python dictionary and JSON. We also could save this to a YAML file as well. And this is a great format that's really emerging with cloud computing, is that it's essentially JSON. It's key value based, but it's more human readable. And notice all I do is I just say with open, right? And I can go through here and I can write this out. And then similarly, load YAML, right? I can do the same thing. So there's lots of ways to do that in Python. Now, the other thing that comes up a lot is creating directories, manipulating directories, moving directories around. I do this all the time. Like if I'm creating, especially like data engineering pipelines, this is something that does happen a lot. Is you need to create something on disk, some kind of file system, or some kind of it's tree structure for things. Using the highest level libraries is the way to go. And in fact, Python has a new one called Pathlib that does a bunch of really fancy stuff. And let's take a look at this. So if I say import Pathlib, all I need to do is say pathlib.path.makedir parents equal true, and then basically build out this directory structure. And if we go through here, take a look at this, you can see that essentially this is actually the directory that it created. And notice that I also can even create files here as well, or directories, by using that same path. So pretty cool that it's a very simple high-level interface to things by using this Pathlib library. You can also even write files with it, which is pretty incredible. Like I just say write text, and if I cat that out, right, it put this into that. So basically, if you are going to manipulate the file system, I think Pathlib is not a bad way to go. Now, here's a good example of using Pathlib to rename files. This happens a lot. Is that you want to to rename a bunch of files. Like there's tons of reasons for this. Working with Visual Studio Code at one point, I had to do a bunch of this when I had to rename a whole tree of C# files to do an upgrade, movie files, backup files, you name it. So how do I do this? I could say from pathlib import path, go ahead and write something to a file. I can print out what it is before, then I can rename it, and then I can print out what it is after it's renamed. So you can see this how it works. Before rename, here's this. After rename, you can see this is how it works. So really, really simple by just using the rename method. And again, you could print out what's inside of here and try things out. The other thing that's pretty cool as well is if you create a path like this, you could also go and say like, hey, give me the full path of where this actually lives, which is also really handy. Also show my current working directory. So you name it, the pathlib is like the kitchen sink of stuff of what you want to actually try out. Now here's an example of using fn match to look for things on a file system. This is something that you could do as well if you want to search for files. There's a high-level tool called fn match, and you can see again I have a function, I do a filter, I return back the matches. If I want to archive things on disk with Python, this is a really good example of from shutil import archive, and notice that you can basically create a gzipped archive really simply by using the archive utility. And then if I want to walk a file system, this also is really, really common. If you want to figure out, find duplicates or find certain file names or whatever, is walking the file system is a great way to do it. Here we go, import OS from os.path, import join, get size for files, directories, files, and os.walk. Go through here and get these working. So here we go. We can say these are the hooks to walk the file system. Import OS from os.path, import join, get size for root, dirs, files, and os.walk. Right, we can go through here and we can walk this file system. I think this is a great little snippet of code to play around with if you want to understand how to walk the file system in Python. It's really, this is the block of code to do it. And notice there's all kinds of different things you could do, rename files, move files, whatever it is you need to do. And then finally, if you want to go and look at maybe the stat, and what stat does is it allows you to figure out the size of a file, the ID of a file, all this kind of stuff. We say result, os.stat, and look, this is the group ID, this is the size of the file. This is also a great way to figure out more metadata about your file system. Finally, subprocess is another really interesting one to know about for DevOps. And in particular, if we look at this one, import subprocess, import shell lex, what happens here is that this is the user input, and then this is the sanitized user input. And basically, you can write tools that are safe, that won't be security risks, because it's able to sanitize the input by using this built-in shell lex program. The reason for this is that you don't want people to put like remove rm-rf or some weird command in there. It will only parse things that are put in a way where they're essentially safe. And so you can actually write your own tools that use the shell lex command as well. A good example of something like this would be if you want to use subprocess, you could use the touch command, and you could touch something and then say, hey, I want to make sure that the UID is 501. And so this would be, again, some kind of like a health check type system. You could easily build this into a deployment script and verify that things are working the way you expect. Another thing that's kind of neat is that the find command is, on most Linux operating systems. And so why reinvent the wheel? What if you just actually built it out yourself by using the find capabilities? And so here's a good example where we do subprocess.popen. I find this and I put it inside of the Python utility. So this is a great way to use existing Linux capabilities when you're building stuff out, and you can play around with that on your own. Also, there's glob. This is probably the simplest possible way to look for things, is you just say import glob.glob, and it'll give you back some matches. And you can take a look at some examples down here. So this is probably a good spot for me to then move back into the shell a little bit, which is now let's get into developing with the command line. And so if we go back to this example here, we say, hey, we know how to do more stuff now. We can talk to the file system. We can also build some command line tools. So let's keep building this project out. Well, how do we do this? Well, what I can do is actually, I'm going to move over to a new environment so that we can test out lots of different environments. So this was the code spaces environment. Let's go over to AWS now, and let's test out how you would verify that this project works on AWS. How would we do this? Well, the easiest way to start with would be to click on Cloud Shell. And Cloud Shell is pretty cool because it's literally a shell that you can run on the AWS platform, and we should be able to mimic every single thing we did on the GitHub code spaces here, although it's only terminal based. But let's just give this a second, and then we should be able to get this going. Okay. Looks like it's waking up. Yeah, I would say the one thing about the Cloud Shell that's annoying is it takes like a minute to wake up, which I'm not sure why it takes so long to do that, but it's definitely, I wish it was more instantaneous. Let's go ahead and see if I refresh this a couple times, it'll wake it up. There we go. So notice what I did here too is I have this .venv here. So I do the same thing in this kind of environment. I just go to the bash rc like this, and I have like a virtual environment. So there we go. We got the virtual environment. The other thing, if you are going to use this kind of development environment for working with GitHub, you do have to give it your SSH keys. We're going to find out. I forget if I've got this set up or not. So I don't. So let's go ahead and set this up. I just type in SSH keygen -t RSA. You only have to do this once, and then you print out your public key, which is the one you give to GitHub, and you run cat and you print this out. Now what's nice about this is I can go back to my environment, into GitHub, go to settings, go to SSH and GPG keys, create a new key, and we say Cloud9 or Cloud Shell. There we go. Perfect. All right, now I can go back to this and I can do get clone. There we go. We have get clone. So I can cd into this project, which is functions. And then remember how I talked about that in theory, you should just be able to run make all. Let's try it out. Let's see if I run make all, what happens. We're able to actually run our Python project. That's great. Everything passes. So I think this shows how flexible this style is. And then from here, if I wanted to, I could develop into this environment by using the Vim tool. And maybe I'll just add a little bit of code. First here, I'll just say like, cap it, we'll say cherry like this, and then I'll print this out. Or no, I don't even need to print it out because it already prints it out. Okay, let's go ahead and do this, and let's go chmod +x, hello, And now if I run this, oh, actually I need to make it executable up here, or I'm sorry, give it the right, I need to give it the shebang line, which should be right here, which should be user bin env Python. Okay, once I do this, I already made it executable. I can just do this. I can do ./hello, like that. There you go. You pass in this word cherry. Now it's the new version cherry. So this is a good spot to push the code in, git status, git add hello. And so we see that this is another decent environment adding more code. But I would recommend instead of this, let's just double check that that code went in here. Let's make sure that our project is working. Let's refresh. I don't think that pushed. Oh, empty, git push, git commit. I think it's having, it doesn't like this, so let's change this real quick to adding my email address like this. And then we'll do this. We'll add this in. Okay, great. And now if we say git status, git commit, adding changes, git push, there we go. Now we should see that change, which should be now. There we go. Right. So I added just a little bit of code here, but this is a little bit of a clumsy environment for developing in. I like it more for like running code or testing out examples or doing AWS things like this, listing buckets or whatever. But I think a much better place that's similar to the GitHub code spaces would be to use something called Cloud9, which if you are doing cloud-based development on AWS is probably the place that you should use. So let's go ahead and do this. It's very similar to GitHub code spaces. Let's go ahead and say, here we'll say Python DevOps, and we'll say this is an environment, and let's put even the date. Let's do 12/2. And we'll say this is an environment for building Python for DevOps code. There we go. Now, what I typically do, if I'm just toying around, the micro is totally fine. It's actually a great environment. Because I'm doing a demo and I want it to be super fast, I'll just make a slightly larger instance here. The other thing as well is Amazon Linux 2, you can use that. I would recommend it. If you are only using Ubuntu, you could pick Ubuntu. I personally like it, and it'll auto time out after 30 minutes. So it's really a great environment for doing developing. So let's go. Let's take a look at this thing. I think this is a little quicker as well than the Cloud Shell for some reason. I don't know why the Cloud Shell takes so long. Even though this says it takes a few minutes, it never does. It takes, I would say, 30 seconds. Well, it's just going to prove me wrong and take a long time, but typically it's very quick. And what we're going to do in here is we'll start building out a command line tool. And in fact, we could even start to build out a command line tool that talks to AWS services, which might be a great way to kind of tie things up into a more realistic DevOps scenario. Because it's one thing to play around with like toy scripts, but it's much more likely that you're going to be building something that is a cloud-based, tool. And so this is a great environment for developing in. And so I would again do the same thing I typically do, which is we're going to have to create SSH keys again, unfortunately. SSH keygen -t RSA is a one-time only deal. Once I do it onto this environment, I never have to do it again, but we do have to do it once. Let's do this, print this, put this into GitHub. Let's go to here, add it in, SSH gbg 12.2 Cloud9. Eventually I'll clean those up. Okay, got that. And now I can go back and clone this repo, which again, we can go here. We can go to this DevOps, or let's go back. Here we go, functions 12.2, and let's clone this. Okay, git clone. All right, now it should work. But we'll have to do the same thing I did before, which is we want to build out a Python virtual environment. In this case, it has the built-in Python virtual environment into Python 3, so I can just do this, right? Python 3-m virtual environment. And then again, I would just edit the bash RC. Let's just be lazy. Bash RC here. And at the very bottom, I just add virtual environment. So we just say source tilde venv bin activate. Okay, and now I don't have to worry about it again. And I can just type in bash. There we go. We got it. Which Python? So if I just cd into functions here, make all. There we go. And this thing should be working. So what I'm going to do next is I'm going to add the Boto3 library, because we're on AWS, we might as well do some AWS stuff. We'll add it into right here, and I'll go to the requirements library and just add Boto3. Now let me show you why Boto3 is a neat little library to work alongside of IPython in Cloud9. If you are using AWS, it's actually really nice. So let's go ahead and do make install, and we'll install the Boto3 now, right? Because I just used this as my source of truth. We can see it installed Boto3, and let's see what Boto3 does. So the first thing you can do is you can say, S3, or first import Boto3, and then we say S3 is equal to Boto3.clients, and then you just put in the name of the service you want to talk to, like this. Boto3. And then we can do S3 dot, and we can do the same thing we were doing earlier. Notice this, it finds all the different things I can do, which is awesome. And I can just go through here and say list buckets. And there we go. Now we've got the buckets created. So pretty cool that I can prototype up stuff and start to build out command line tools and all kinds of really neat things just by using the IPython and Boto3. And so in order for us to do a command line tool though, what I'm going to need to do is install this click library, and we can just do that. And I'll again say make install. And the way I would build out something like this is that I would again start to build out my logic by playing around inside of I would play around with actually IPython. So one of the tools here, and let's move over to console here. One of the tools that's a really cool tool on AWS is something called comprehend. And let's do that. Let's do a little bit of AI here. And let's take a look at Amazon comprehend. It can do all kinds of different things, like from let's just take some text from I don't know, ESPN, and let's just grab something. I don't know, MLB shutdown. Great. Okay, let's just take this and we'll go and we'll grab a little bit of this text here, and then let's close this out and let's just put this into here. What does it do? Well, it can do entity extraction. It can find all the different entities out of here, which is pretty cool. It can find the key phrases. It also can do language. You can say it's English. It can do sentiment. It says it's neutral. It's confident that this is neutral. It can also look at syntax and find the nouns or the verbs. So it does a lot of really cool stuff. And so what we could do is we could write a command line tool that uses this comprehend service. And fortunately, it's really, really simple to do. And that's where we could actually go through here and say IPython. And so if we want to go through here, I can again just say comprehend, or I first import the library, import Boto3, do comprehend like this, and just say Boto3 dot client and say comprehend. Right, this. And if we say comprehend dot, it'll do the same thing. It shows all these different like things that I can do with it. So first I'll put some text in here, and we'll just say like, today is a great day. And now we just need to look at the way that this will actually take in a payload. And so I think a good one would be to look at the sentiment. And if I do a question mark, look, we can use that trick. We can see it's going to take, it really just needs the text and it needs a language code. So that looks pretty easy actually. So let's go ahead and do this. Let's say comprehend to text sentiment, and we'll do this. We'll say text equals the text that I just built, and then language code is equal to English. And then I can do Control A, I think, to get to the top and say results, and then do this, go to the bottom. Now look, results is positive, right? So I can basically do this. I could just take the, there we go. So we can use everything we talked about. And so let me just briefly talk about the Boto3 library really quick. So how do you find out more about it? So Boto3 it's basically the AWS SDK for Python. And if you want to learn AWS, which is the most popular cloud platform, I think Boto3 is a great way to learn it. And in fact, you can see here, there's all these examples, quick starts. But if you take a look at the available services here, it's staggering. Look at this. I mean, there's hundreds and hundreds of services on AWS that you can talk to. Every single service that you could think of, you can talk to it via AWS. I mean, SMS messages, SimpleDB, Route 53. I mean, you name it, you can do it. Whatever it is, we're doing the service called Comprehend. We could take a look at that real quick and see AWS Comprehend. Where is it? Right there, AWS Comprehend. And so in this case, this is what I did. I just said, make a client, and then look, I can even find all the different services available and just even look at the documentation. So look, detect sentiment, we can click this and it tells us exactly how to deal with it. So great, we have this thing working. Now let's start to build this into a more sophisticated command line tool. So in order to do that, I need to use the click library. And so I'm again going to borrow from myself here, and I'm going to find something that I've done in my GitHub that I can just copy, and we'll just look for click. Here we go, Python click cookbook. This looks good. And I'm going to just grab one of my examples here, and here we go. Import click. This looks like a good example to play around with. So I'm going to go to raw. I'm going to copy this, and we'll just go from here. So we'll go back to this, and we can bring this. Let's just delete this stuff. We don't really care about that, but we can put this at the top. There we go. We got a click command line tool here. That's looking good. And I just need to import click. And there's a couple ways to start building this thing out. I personally like to have my logic in a different file. And so let's just open up a new terminal here, and I'll cd into this. And I'll just create a file called logic.py. And inside this logic, we can build something like we were just doing earlier in this. Like we'll just build something that can detect the sentiment. So I can essentially almost take this code verbatim and just build it out. So I can say import Boto3, and then we can say def, we'll just call this sentiment like this, and all it's going to do is it's going to take some text. That's it. And so what do? We just say, let's make a client here. So put this in, and we could even put a doc string as well. Just say this detects sentiment like that. And then what we do after that is I would go through and I would pull this into a function, just clean it up a little bit. So we don't need this, we don't need this. Gonna get that going. So you can see how IPython really is pretty nice, because it serves as a form of development environments, and then later I can steal the code for myself. There we go. It detects the sentiment, and then we just want to return back this. We just want to return back just the sentiment value. That's all we care about. There we go. Result sentiment. It looks pretty good to me, and we could even test it out really briefly by actually using IPython again. So let's go ahead and do this. Let's exit, and let's say from logic or IPython, and say from logic import sentiment. And now all I do is I just say sentiment, this is bad. And we need to capture it. We say result is equal to print result. Oh, we need to return. We didn't return. I'm like, what's going on here? Return result. There we go. So let's exit. Let's re-import this. So with IPython 2, it's pretty neat. You can just do up arrow, and it'll remember everything you did. So you can just go through here and then say sentiment, this is bad. There we go. Negative, say this is good. There we go. Right. So we're using a function again. There's an input. There's a unit of work. There's a return statement. We're doing something with this, and so what do I need to do to then build it into command line tool? Well, pretty straightforward. I can actually go back to this hello here and actually just import the logic, right? So I just say from hello imports sentiment like that, and then we just change this. We just say text. So this will be and this will say, we don't want a prompt as well. We'll just say this, we'll say type in a phrase to get the sentiment. There we go. And then we'll change this as well. We'll say make sentiment, and this will just be the text. So this has to match with this dash text has to be text right here. That's the way that this is actually parsed. And we'll just say detects the emotion of a phrase. There we go. And now we can just get rid of this. We can just say, no, actually, I'll keep that back. We'll say result is equal to sentiment, and then will be the text. That's it. That'll actually give us the sentiment. And then from here, I just go through here and I say, I could even say if negative, right? We could actually make it do something kind of fancy. I just say if negative in results, then we basically make it red. So we say just put the word results, and then I just go like here, and then I just go else, and then say this, and I do, I don't know, like green, like that. And then I just changed this to the bottom, and I believe this will work just like that. Perfect. And then this capital thing, I guess it's kind of dead code, but maybe what we'll do is from logic import sentiment. What we'll do is, I think the easiest thing to do would be for us to rename this file. So instead of hello, we'll call this CLI. And then we'll make another file called hello and just put our other code inside of there so it's not thrown away. There we go. And paste this back in. Okay, there we go. So this is just kind of dead code from our other example. We have a command line tool here, and it imports the logic, and basically this parses this option text, and then we go through here, we make the thing detect the sentiment. So let's go ahead and run this. First I make it executable, chmod plus x in the CLI, and then I just run it, see what it does. Uh-oh, it says doesn't like something that we did, which is not a surprise. Let's take a look at this. So it says, well, we didn't call it with help, so that's probably one problem. Let's do help. Okay, so this is better. It shows us the output. It says detects the emotion of a phrase. Type in a phrase to get the sentiment. Okay, let's go ahead and try it out. Let's type in text and say, like, today is so great. Positive. Today is so horrible. Woo, today's so horrible. Negative. There we go. We got a working tool. So now that we've got this working command line tool, the next step would be to just tweak it a little bit so that the test or the lint is able to lint our code. Let's double check and say make lint. And there we go, that's good. And we would just add another test here, like that would basically, test our code a little bit more. I mean, we could do this, that we could just test only the logic and not the command line tool. So we could say from sentiment, import something. But because it's Boto3, we'll leave that as an exercise to the reader, whether you wanted to do some kind of mock to get rid of this or whatever. But the main thing is we got a command line tool. It talks to AWS. You could do obviously anything you'd want to do with cloud computing. So let's go ahead and push this code. So let's say get status, get add, all this stuff, and get status again. We see all those files are going to be committed. We'll say commit. I think it's going to get angry again about my name. We'll fix that. Adding CLI. Of course, it doesn't like that. Let me just fix it real quick. Go through here. Again, these are kind of one-time annoying things you do the first time you work on a project. You don't have to, in a new environment. This is why it's probably good to stick with one environment. And then we can reset the author. That way it knows who I am. And then we can exit this. It looks good. And I can say get push. And now we can go back to our project, refresh it, and this should be able to run our code here. There we go. That looks good. Let's look at Github Actions. Is it still going to be successful? We're not testing everything, but we're testing a decent amount of stuff. And so if this passes, we're in reasonable shape. According to AWS, this is actually one of their best practices. So if we go to microservice here, what we want to do is we have a function again, and that's the unit of work that we want to do the same thing. We want to have an input, and we want to have the work, and then we want to have an out. And really pretty straightforward to do this. This is step one. This is step, we'll call this the work. This is step two, and this is step three. It's easy to do this because we can build a microservice using either FastAPI in Python, or we can use Flask. They both are great frameworks. It depends on, which. Flask is a little bit easier, but FastAPI has a little bit more power for microservices because it has Swagger built into it. So let's go ahead and try FastAPI here to build out a microservice. So what I'm going to do is I'm going to shift gears here and go to a demo project I have called Gift FastAPI, and let's just look at some of the components of this particular project. And so the first start of it, we see this, we have the makefile, all that stuff. But the key part is this file right here. And notice that it's pretty straightforward. There's just a few lines of code that allow us to build something. So I'm going to just copy this essentially. And I'm going to go back to this project here, and we'll just create a main.py. And let's go ahead and do that. For some reason, there we go, touch. Wait, mv main to main.py. There we go. We got a main.py here, and I'm just going to throw this in there, and we can just import FastAPI. And let's just double check how I did this before. What did I put in here? Requirements. Okay, so it wants these two things. It wants UVcorn and FastAPI. Sure, let's copy this. Let's go back here and go to the requirements. We don't need that. We already have that. We don't need this. Okay, so I'm adding basically these two, FastAPI and the web server that will run it. And then I'll just do the make install again. So say make install. And whoops, I need to save it, then do make install. There we go. So this should take a second. All right, we got this working. Now if we look at this main.py file here, in this case, let's change it. We'll say hello DevOps, like this. And this is probably okay to start with, but I'm going to make it a little bit fancier, which is that basically this adds two numbers together. Look what it does. It says add number. Let's just run this first to just see how it works. And I'll just say make, I'll just say Python app, Python main. So this runs in foreground mode. And what's kind of cool about this is that I can actually get this working if I wanted to by actually running this into a web browser. And so what I'm going to do is I'm going to go to the console. I'm going to find my EC2 instance that's running, because that's what Cloud9 does, and I'm going to open it up so I can play around with it. So here we go. We see one instance is running, this one. If I click on it, I can go to the security, and I can go down here, and I could say, hey, let's go ahead and tweak this security group so that it's able to accept inbound traffic. So let's go ahead and do this. We'll say custom. That looks good. We'll say port. Actually, what port is it running on? It's running on port 8080. So we'll do 8080. And then from here, we'll just say anywhere 0.0.0. We'll say FastAPI test, like that. And then we just say save. And what that means is now I can go back here and I can just click on this address, which it should open up in a second. I'm gonna have to open up one more time. I can go to EC2. I can click on this and I can just go like this. This is a better way to do it. Go here, wow. Copy this and do 8080. There we go. So we see that it's running. And in fact, if I go to Swagger, no, where's the, I forgot how you get to the documentation for FastAPI. It's under FastAPI Swagger. Let's see, how do you do it? You just go to docs. So we go to docs. So I'm going to go to here. I'm going to go to docs. There we go. So pretty cool, right? I get this built-in API documentation here. And so I can actually go through here and I can just say add 2 numbers, like try it out. And we can just do 2 and 2, execute. There we go. Look, it even tells me all the curl commands, all this really cool stuff. It gives us back a response. So kind of a cool little trick here that we can actually use this microservice with documentation and everything, and it's all just running right here in foreground mode, right? Like I can actually go through here and play around with it. So the next thing that I can do is actually make it a little more tricky by doing a couple different things. One is adding that logic that I did before. So notice here we have the sentiment. Let's go ahead and make an endpoint for this. Let's actually test this out. So I'm going to close a bunch of the stuff to make it cleaner. So I'm going to say from logic import sentiment. Let's do that, sentiment. All right, save that. And then I'm going to add a new route, which is this. And let's go ahead and add this route in. And we can say in this particular route, we're going to say text, and we'll just take in just some this will be like a phrase, or we'll tell it to do a word, because just to keep things simple, and we'll say this will be text, and this one will be, hopefully this will work here, and we'll say, here we go, text string, something like this, and this will say detect sentiment, and we can say sentiments, we'll say result is equal to sentiment, and put in the word like that, and then we'll say emotion, and then we'll say result. There you go. So this in theory should work. Let's see, undefined variable word. Oh, because I need to say make this word like my text. Or no, add, that works good. And this would be word like that. I think this should work. Okay, so now in theory, I can close this, launch it again, and if I go back to this environment here and we click on this, there should be more stuff in here. Let's refresh this. There we go, that works. Let's go to docs. And notice now there's a new endpoint. And we can just say try it out, and we can just say word happy. And what happens? Believe it or not, first try, we have a full microservice working. So this really, in my opinion, shows the power of something like a FastAPI. And so really the only other thing that we would need to do to deploy this in production, I'm going to kill this for a second, is I'm going to go back to my other example here, and I'm going to find this Docker file, and notice that it's right here. And let's just copy this. Let's copy this code here, and then I'll explain what it does. So we'll call this Docker file. And so the idea with containers is everything is moving to containers now. So basically, if you build out things with a container, it just makes your life easier, because most of the web services in particular will allow you to accept, payloads from other services. And basically it's an easy way to build out these pipelines. So notice what it says here. It says from AWS ECR Lambda Python 3.8. It goes through and it gives us this as the base image. And then what I do is I make an app directory. I copy this main file in there. I go ahead and I pip install it, and then it goes through and it runs this. So basically, it's similar to what we're doing currently. And in fact, I should be able to basically push this container directly into Amazon's container registry as well. And so let me show you how that would work. And so the way that this would work, I mean, I guess I could first say Docker build to just test it out. Docker build, and let's just double check we've got everything here. Let's go through here and let's just double check how we do Docker build. So it's going to say Docker build that, and let's go ahead and do that. So let's run this command. Okay, and this should download the container and then wire all this stuff in so that we can test this microservice locally. Let's go ahead and test that out. And this is another reason why it's good to have a more powerful, like a build environment like the bigger Cloud9 instance. Okay, that looks pretty good. We got this thing running. And now, once this is up, we can just say Docker image ls, and we should see this is the image ID here. And then I would just again go back to my example here and say, I would just say Docker run with that image ID. So let's go ahead and try it out. So do this and then put in this image ID, and this should let us test it locally. Okay, again, does it run? We can curl it in another shell. Just say curl localhost 8080. There we go. So it does work. So, and we can see it working here. So this again is probably the first step, because once you do this, then you can deploy it into higher level services on AWS. And so I'll just push this code real quick. So let's go and add this stuff. Here we go. Adding Docker and FastAPI. Okay, push this. So why do we care about all this stuff? Well, one of the things that we can do that's kind of neat is if I go back to console here, there's a service I've been playing around with a little bit called App Runner. That's kind of nice. And this one allows you to very easily build complete end-to-end solutions. Look what it does. So let me make this a little bit bigger, is that basically you link to source control or container, and then it essentially creates a complete end-to-end microservice with HTTPS credentials. So if I click on this, create an app runner service, notice it says container registry can be one of the options. So what we need to do is get our service into Amazon's container registry. And so how do we do this? Well, let's go over to ECR, which is their container registry service. Here we go, Elastic Container Service. And notice that this is where we want to go, to repositories. And once you're inside of here, we can actually go through and build out our own repo. I'm going to go ahead and just delete some of these so I have more room, and just do this real quick. Delete it. It's always a good idea. Type delete. Okay, type delete. It's always a good idea to clean stuff up that you don't need. Let's do the same thing. We'll say delete, and then I'll just start over from scratch. Okay, there we go. Delete. So first thing I'm going to do, create a new repo, and we'll just call this one DevOps. And one of the things that's pretty cool actually is that you could, if you wanted to, scan it for vulnerabilities, which is a nice security enhancement. It looks like they're changing this to some other thing called registry level scan filters. But let's go ahead and create this. Now, how do I push it into there? It's really straightforward. You just click on this button and say view push commands. And so we just literally run through these 4 commands. So step 1, let's copy this and go through here and paste this in, get login. There we go. That's good. Step 2, go through here, Docker build. And so this is going to now build a version that's specific for us to push to ECR, which then gets us to the point where we can actually deploy this using AWS App Runner. Okay, that looks like that works. And now let's run the next command, which is going to tag it. There we go. And let's push this. And now we'll do the final push. And it's going to be very fast when we do the push to the repo because of the fact that we're already inside of AWS. So the call is coming from inside the house to make fun of that horror movie, right? We're inside of AWS. And so it's going to be really fast to push this code into the ECR repo. Let's just give this a second. You can see it all going over there. And the beautiful thing about containers is that I can then check this out anywhere and I can run this container and it's just super fast. There we go. So now all we need to do is go back to here. Let's double check that it's here. We've got it. There we go. And now let's go to App Runner and let's tell App Runner about our new service that we've got set up. We go here, we create an App Runner service. Now we can use this option, container registry, right? You can notice that it allows you to connect either to the Amazon public repository or to the Amazon ECR private repository. So those are the 2 options that it gives you. We're going to select this container image URI. I'm going to click on browse and we can just pick, there's only one, right? That's the one. And that's why I like to clean it up just to make it easier for a demo. Now, if we scroll down here, we can choose how we want to do this, either manual or automatic. For DevOps, this would be continuous delivery. You would want to select this, where basically every time you did a new build with, let's say, AWS code build, you would actually automatically do a deployment. In our case, we're going to manually deploy it though, right? I just want to do a demo. And it says this role gives App Runner access to ECR. Let's see, there we go, App Runner ECR access role. We'll go ahead and use that. Service name, we'll call this FastAPI DevOps, and we can leave all the stuff the same. And one tricky bit here that will be a problem that is a little bit crazy is that because we're using the AWS API, we don't actually have exactly the kind of instance role that we need. So we're gonna have to fix this. So look at this. It says select an IAM role with permissions to do a service call code on your behalf. Look, it couldn't find any role. So we're going to need to create an instance role. Let's double check here for, if I go back here, let's just double check. We have to get this right because of the fact that we're making calls to the comprehend service. And let's just double check security. Select an IAM instance role with permissions to call the service on your behalf. And in fact, let's just look at this. It says an App Runner service. So provide an instance role, use this IAM role. And so configuring an App Runner service. When you create a service, you set different values. And I believe we can do this with the IAM environment. So let's see if this works. If not, I'll just won't run that part of the code. Let's go to IAM and let's set up a role here. Hopefully they have added this, because this is a really new service, and so there wasn't actually a role set up for App Runner as of even a couple weeks ago, but they may have fixed it. I don't see App Runner here. Let's see here. Let's see EC2. Let's try this. EC2. Let's look at App Runner. App. Huh. It's very interesting that they have this runner. It's very interesting that they have. They haven't. They say that you need to do App Runner service. I'm not going to worry about it because I'm not going to call that part of the code. There's a different way I've done this in the past, which is I do encryption keys. But this is just one gotcha with this particular service. So let's go through here and we'll say App Runner, DevOps, and then we can go through here and just run this thing. So DevOps. Here we go. Next, close this, and we can go create and deploy. So what this will do is that it will then create a full functioning URL or a microservice that we can run our code against inside of here. And so in theory, this is actually pretty cool, because let me just maybe whiteboard this up, because this is going to take, I would say, 5 or 10 minutes to set up. So I don't want to wait the whole time for it. Let me just whiteboard out what this thing is doing and how we could actually use this in a real world environment. So typically what you would do is, let's call this a DevOps, microservice, AWS, DevOps, AWS, and we'll call this microservice. So in particular, we would go through here and first have our code in GitHub, and we did all that really fancy stuff, and we could test it in a couple different ways. I mean, we could test it either with actions, which is what we were doing, or you also could test it with something called AWS Code Build. Either one is suitable, although if you're going to build a container, probably you would want to do AWS Code Build here, because what Code Build could do is it could automatically push. I mean, you can do the same thing with GitHub Actions, but it is probably a little bit cleaner to do the push of the built container to ECR, which is what we just set up, the Amazon Container Registry. Once that container registry is set up, what's cool about it is that basically this is in fact continuous delivery. So we'll say that's continuous delivery, and the reason why it's continuous delivery is that it will constantly rebuild, right? Like this would be rebuilding this container every single time we push, and then the AWS App Runner service can actually go through here, and it can actually build out the pushed version into a new, we'll just call this service or whatever. It would move out that service every single time it runs. So this is full continuous delivery, but a container-based continuous delivery. And so let's take a look at how you could do that with, let's take a look at Code Build real quick and why you may want to use Code Build for that. So what you could do, if we go back to this, is we could go to Code Build, which is right here, and look at this. It says build and test code, that you could actually create a new build project like this and do the same kind of things that we did with GitHub. You just go through here, you go GitHub, and then eventually what you would do is you would go through here and you would run your build steps, build commands. You could switch an editor, and you would just literally push your container inside of these build commands. And then basically, because App Runner itself can listen to the new build in ECR, or the new container that was built in ECR, then that's it. That's your entire deploy process. So this is a pretty clean way to do it as well. Very, very similar, this code build process to using things with GitHub. And you can see I have some other projects that I've done in previous demos where I show people how it works. The code build, I think, is a great part of a container-based workflow. The other thing that I can talk about here as well is that notice that I had that other project. We can do two at the same time. Notice this is this FastAPI project that, and again, this is a really simple project that just adds two numbers together. Let's just build two at the same time. So let's go back to App Runner here. And while that thing's working, let's make a new one. And let's just say create service. This one will be source code based repo. So we could, this one maybe would be cleaner to just only talk to GitHub. You can, again, do lots of different ways to do it. And if we go through here, we can say repository. And I think the one I'm going to want to do is FastAPI. So let's see if we can find this FastAPI. There we go. Main branch. Same thing. I'll just deploy manually to start with. This one, there's really nothing tricky I'm doing here. The build command would just be pip install -r requirements.txt, and then the command would just be literally python main.py, just like that. And then if we go through here, we say next, we'll say FastAPI, GitHub or something like that. FastAPI GitHub. And we don't need to do anything because there is, all it is adding two numbers together, and we can go through here and we can push it. So there's a couple different varieties of deploys that you can do. This would be the container base, and this is a regular base. Now let's go ahead and see if this one works. Okay, so this one does work, but if I go to I go to the docs here, there we go. See, I can actually start to play around with this. This part, this adding should work. Let's try it out, and we can just say, 5 and 5 should be 10. There we go. So, I mean, this is pretty cool because we were able to just really quickly just build this microservice and deploy it. I suspect this one will not work because I would say I'm 99.99% sure this will not work because we didn't set up the IAM role, which is a little bit tricky, and kind of this part of the App Runner service is a little janky. There's a way I've done this before with API secrets because it can keep track of secrets. But let's go ahead and verify that we'll call this horrible because it will be horrible. It'll blow up. There we go. It's exactly what I expected. It says, hey, you can't do that. We've got problems. But again, pretty cool that we were able to get this thing cooking via a container-based workflow. The other one should be up in a second here. And let me show you actually how you would do API-based secrets. So what you could do, that's kind of neat, if you wanted to talk to Slack or talk to GitHub API or whatever, some other cloud service, we could do that. We could just do source control, do all this stuff. Again, we'll add FastAPI here. And then look how we would do this. We would say runtime Python, same thing, pip install -r requirements.txt, same thing. We would just say Python main.py. And then what I could do, and just call this secrets or something, is that notice add environmental variables. That's where we would do this. So these, we could actually pull these out of the environment, and this could be like, Slack API, and then this one could be, Boto3 key or whatever, and then you could also have, I don't know, GCP key or whatever, and you could pull those in and then inject those into your code. And so that's typically what people would do if they were going to deploy this with the API secrets. And so it does have, that is one way to do it. I personally prefer not to even these encrypted secrets here. I prefer to use role-based privileges, and that's why this role-based way to go is a good way to get this working. I have not figured out which role they're expecting you to use there, because there is nothing for there. Because for example, with if we go to IAM here real quick, a lot of times when I'm using Lambda, you can literally click on Lambda, right? Which is, if we go to roles, right? What's nice about this is that these are the most common IAM roles I use. I use EC2 and I use Lambda. In this case, it's unclear which one they want you to use, and I don't see it anywhere inside of here. So, I don't know why they didn't do that, but maybe it's under active development. But again, the workaround could be that instead of doing the role-based privileges, you could do this. You could do IAM, and you could create a user, which I don't like. Again, add some user, make it a service account, call this like service account or something like this, and then you would just create access keys and then put those inside of those environmental secrets. A little bit clunky in my opinion. I think the role-based privileges are really the way to go. And so maybe the last thing that I'll show you with the microservices is that beyond just App Runner, the other one that I use a lot is AWS Lambda. And let's go ahead and take a look at that real quick. And if we go to AWS Lambda here, that it also works really well for doing the kind of stuff we've already covered, which is using a function, and then there's an input, there's an output. So let's take a look at this real quick, how you would use this with Lambda. So what's great about building things with AWS Lambda is that it really is very straightforward. And in fact, we can get that piece of code working that I was trying to get working earlier. Let's go ahead and do this. So let's go ahead and call this. Let's first build a really simple one, which is let's take something from what we've already done. Let's just grab anything. Let's see, logic. Yeah, let's do this. So let's just grab this. This is probably a good one to play around with. So let's go to Lambda here. And we'll call this hello emotion, and we'll say runtime Python 3.9. And notice you could pick x86, which would be probably what you would want to do if you are caring about modern libraries. If you're just using straight Boto3 or something like that, this might be a good choice because it's cheaper. And then also, this is where you would really get yourself into trouble unless you have the right role. So again, this is what's interesting, is they have execution roles for Lambda, but they don't make it clear, at least for App Runner. I'm going to use an existing role, and I'm going to pick one. Here we go, an admin role I had set up earlier, and I can go to create function. It's really straightforward to get the functions working here. Is that I would go to this section here. This is pretty cool. They have a Visual Studio Code type interface here, which is awesome. This is new. So if I go this, notice what happens. I say import Boto3 sentiment, but I actually want to tweak this a little bit because I want the Boto3 to be there, and I'm just going to keep this function up here. And what I want to do is I'm going to basically I'm going to do this Json dump, and this will be, in fact, the results. So let's do this. Let's do results like that. And then we can do our to-do. The implement is, again, unit of work here. We just say event. This will be text, and we'll say text is equal to event text, like that. And then I would just say results is equal to sentiment, and we put in text, just like that. So really, it's just a couple lines of code to get this thing working with what we were doing before. I'm going to go ahead and deploy this. And now I'm going to test it. And it's going to give me this test function. I'm going to call this negative. And we'll just put in a phrase here. We'll just say text. And then do this. And we'll say, this is a bad day. And we'll say format JSON, create this, and then go ahead and test it. What happens? There we go. We have a negative payload here. So, I mean, incredibly simple to build this into a Lambda function. And if we go back here, we can actually do another test. And in this case, we'll build positive, and we'll say, this is a great day. Like that. Format it, create, and we can go positive. There we go. Right. So really, really simple to get this thing working. And then what's very interesting about once you've got something like this set up is that it's easy to invoke it from the other development environments. And so if we see hello emotion here, what we could do is we could go back to this environment here, and we could in fact even pull it up, which is kind of interesting. So if you look at this AWS tab here, notice that it's got a section for all these common services, and in particular we have Lambda right here. And what did we call that thing? Hello emotion right there. So let's double click on it, or right click on it and say invoke on AWS. And if we click on this, look what it does is it lets us invoke this thing. And so we just scroll down here and we say, well, we don't even need to do anything. We can just put our own payload in here and just say, the text would be text here, and then it would be, this is a great day. Just like that, invoke it. There we go. And we got this thing running remotely.